All right, let's jump right into this explainer. Think about it for a second. How does your phone just magically know it's your face and unlock in a fraction of a second? Or how does your email inbox know exactly which messages are total junk and which ones actually matter? Well, it all comes down to an absolutely fascinating branch of artificial intelligence. Today, we're diving deep into the foundations of supervised learning. Even if you follow tech pretty closely, the underlying mechanics of how these systems actually learn is just mind-blowing. It's one of the most widely used machine learning methods in the modern world, and by the end of our time together, you're going to understand exactly how the magic happens behind the screen.
To keep things super clear for everyone, here is our roadmap. We are going to cover 1. What is supervised learning? 2. The fruit learning example. 3. The 4 core steps. 4. AI in your daily life. And finally, number 5. Limitations of the system. Let's get to it.
Starting off with Section 1. What is supervised learning? The AI classroom. This actually builds on a concept we are all incredibly familiar with, which is a student learning from a teacher.
So, the formal definition is a machine learning method where AI systems learn from labeled data to make predictions or decisions accurately. But, what does that actually look like in practice? Well, think about a traditional classroom. A teacher doesn't just hand a kid a blank test and say, "Good luck," right? They provide questions, they give the correct answers, and they offer feedback. Over time, the student studies those patterns, connects the dots, and improves. Supervised learning works in this exact same way. The AI is our student, and it's studying examples that already have the correct answers attached to them. We're essentially giving the computer the answer key right up front so it can learn the rules of the game.
Okay, let's move on to Section 2, the fruit learning example, or as I like to think of it, flashcards for computers. Picture a teacher showing a young student a picture of an apple and verbally saying, "Hey, this is an apple." It's basically a flashcard. After enough practice with these labeled examples, seeing a green Granny Smith or a big red Honeycrisp, the student eventually just recognizes the fruit totally on their own. Supervised learning follows this exact same process. If we want an AI to recognize a cat, we absolutely do not just show it a random picture and hope for the best. No way. We feed it thousands of images explicitly labeled cat and thousands more explicitly labeled not cat. The AI obsessively studies these digital flashcards, comparing pixels and shapes until it learns the underlying visual relationships.
So ask yourself this: why do examples with the correct answers help AI learn so much faster? Well, think about learning math in school. At first, teachers show you solved examples. Because you have the answer key to guide you, you learn the actual formula instead of just blindly guessing. It's the exact same for AI. That guidance gives the algorithm a massive head start in recognizing patterns before we ask it to go out and solve problems entirely on its own. Next up is Section 3, the 4 core steps, how AI studies for the test. We've got the flashcard analogy down, so let's look at the actual methodology here. This perfectly illustrates the journey of our digital student. Step 1, collect data. This could be anything: images, text, audio. You just need a massive pile of raw information. Step 2, label that data. Humans literally step in here and tag things as dog, cat, spam, whatever. Then Step 3. This is where the magic really happens. Train the AI. The system runs through all that data, studying the complex mathematical patterns connecting the inputs to those correct outputs. It makes a guess, checks the label, and adjusts its internal wiring over and over again. And finally, Step 4. Test the AI. We hit the system with brand new, completely unseen data to see if it can predict the answer on its own. It's the ultimate final exam to prove it actually learned the concept. All right, let's transition into Section 4, AI in your daily life, from fruits to spam filters, because this isn't just theory, it's scaling up all around us. Now, it's super interesting to see how those 4 steps apply to something you probably deal with every single day, your email spam filter. The AI was trained by studying thousands of emails meticulously labeled spam and thousands more labeled safe. During that phase, it learned to recognize the hidden patterns of junk mail, like suspicious links or really aggressive advertisements. Because of that extensive training, the AI now acts like a bouncer. It catches those annoying emails and confidently filters them out before they ever reach your inbox. It is running that exact flashcard comparison in a fraction of a second.
But it goes way beyond just organizing your inbox. It is actually wild to realize that the exact same basic process predicting a thunderstorm is also helping a doctor detect a disease. In healthcare, supervised learning lets doctors analyze medical scans, basically using an X-ray as a flashcard to detect anomalies early. It's the exact same foundational concept powering your phone's face recognition so it unlocks securely. It curates your online shopping by learning from historical customer data, and it even forecasts the weather by studying climate patterns.
It's just an incredibly versatile tool that seamlessly adapts to whatever labeled data we decide to feed it.
Which brings us to Section 5, Limitations of the System, the catch. Because while this powers our modern world, it is absolutely not magic.
The reality is that this system requires immense human effort behind the curtain. We need people to carefully label massive datasets to make this work, and that takes a staggering amount of time, effort, and money. But beyond the cost, there's a deeper limitation here. It's a sobering thought, actually. The AI doesn't truly understand what it's looking at. An AI doesn't know what an apple tastes like. It doesn't know what a cat feels like when you pet it. It is merely following complex statistical patterns that it mapped out during training. It's a math genius for sure, but it has zero real-world comprehension.
And that leads us to the golden rule of computer science. Garbage in, garbage out. An AI is quite literally only as good as its human teacher. If you feed the system good, comprehensive data, you get high accuracy and really reliable predictions. But if the training data is incorrect or biased in some way, the AI is going to produce poor, unfair results on unfamiliar data. Like, if a facial recognition system is only ever trained on flashcards of certain types of faces, it is naturally going to fail when presented with a face it hasn't seen before. It simply doesn't have the math to process it. This is exactly why data quality is so crucial.
To wrap up our explainer today, I want to leave you with a bit of a provocative thought. Think about your own life, your specific workflow, or even your hobbies. Now that you know exactly how labeled data teaches a machine, from a simple Apple flashcard all the way to a complex medical diagnosis, what kind of data would you collect? And what specific problem would you train your own AI to solve? The possibilities really are endless once you understand how the machine actually learns.